So, greetings, students. In today's lecture, we'll be dealing with your EMF equation of your DC motor. Okay. Sorry, not DC motor, DC generator. Because in the generator only, your output will be your electrical quantity. So, for your DC generator only, you can find your back EMF. Okay. So you already know the principle of your DC motor, right? So when the armature winding of the DC motor starts to rotate, okay, it cuts your magnetic flux to produce your current. Okay, so that's the main principle. Now you have to determine the direction of the current or the EMF. So the direction of the EMF is given by your Lenz law. So what the Lenz law says that whenever there's an induced EMF, okay, I have already said that there will be an EMF as it cuts your magnetic lines of force. It is always in such a direction that would produce the current that it produce will be opposes the change which cause. So this is an important thing. So this is more or less in align with your Newton's laws of Newton's third law. So as per this, for every action there's an equal and opposite reaction. Similar to that, the current produced through this will be always opposing your induced EMF. Okay. Hence, this induced EMF acts in the opposite direction to your supply voltage. Okay. So if you are giving your supply voltage from positive to negative over here, means your current flow will be in the reverse direction. So your induced EMF will be in this direction. That is, your EMF will be in this direction. Then your current will be in its opposite direction. So here your main equation for your back EMF is that EB equal to N phi ZP by 60A. So this is your main equation. So here this N represents your speed of your rotor shaft in RPM. Phi is the flux per pole. Z is the number of conductors. P is your number of pole pairs. Okay. So next we will be dealing with your voltage and power equation of DC motor. So here the voltage EM, if you have to apply KVL over here, you have to apply KVL over here. If you apply KVL means your voltage, so here it will be EB. So here there will be a drop in your armature. Okay, so it is a winding, so the armature drop will be IA RA. So if your supply voltage is V, means your V equal to IA RA plus EB. So this is what your equation looks like. Okay. So now if you have to multiply, we need power equation, right? So for the power, you have to multiply with your armature current IA. Okay, if you're multiplying, this means you'll be getting V into IA will be the electric power supplied to the motor. Okay, to the motor, and the electrical equivalent of the mechanical power produced will be this EB into IA. That is your back EMF power. Okay, so this contributes to your losses. IA square RA, we have already seen about your copper loss, okay, in your transformer. So this will be contributing to your losses. So here for EBIA is your electrical power, which will be equal to the input power minus of your losses. So your gross EBIA is your mechanical power. EBIA is your mechanical power, will be equal to the input power minus losses, which is given by PM. Okay, which will be equal to your EB into IA. So force on the armature conductor is given by your Lorentz force. So as per this, is as for in case of a motor, you'll be taking with respect to your force, and this force is given by your Lorentz force. F is equal to BIL sin phi, sin theta. So here when the theta is the maximum, then it's 90 degree, you'll be getting the maximum of F equal to BIL. So that's what here they are given. So this happens when they are perpendicular. When the conductor and your magnetic lines of force are perpendicular, this happens. Then coming to the torque equation. So as per your torque equation, it's nothing but your power. Okay, how much amount of mechanical power will be always equal to the of your torque equation. So as per your torque, T is the torque in Newton meter, omega is your angular velocity in radian per second. So your PM will be equal to T into omega. Okay, so here, this is a torque and this is your angular velocity. So next here EB equal to your back EMF. Now you have to substitute your EB, that is the power, the PM. Okay. So from this your torque equation is given as T equal to 0.159 PZ by A 5 into IA. So here it is very clear that your torque is directly proportional to the flux generated and your armature current. So this is an important criteria that you have to know. So if your armature current increases means the amount of force produced in the motor also increases. So this is the basic principle. Okay. So here there's a omega, right? So this omega value will be equal to 2 pi n by 60. So omega is nothing but your angular velocity. So this is what with respect to your torque equation and power. Thank you.